All right. Domain and additive property of inequality. So domain, anybody know what domain is? Have you guys heard of domain in math before? You have. Corey, do you know anything about it? Okay, awesome. So domain means the input values. Okay? The domain is the input values. At some point, you guys will learn the range, which is the output values. Okay? So if I go to the store and I buy 5 t-shirts, okay, and they each cost me $5, the number of t-shirts that you buy is the domain. And the amount of money that you spend is the range. Okay? So I get to choose. I go to the store. I buy 5 shirts. So that's the input. All right? The output is that cost me $25. So that would be the range. Okay? I am recording. All right. So go ahead and write this down. X is greater than 2. And then we have this new little thing added to this. This D equals brackets, real numbers. That's important. Definitely write that down in your notes. D equals real numbers. All right, D meaning domain. Okay, what is going to happen is we're going to start restricting our domain. However, real numbers is what you always do. So if you see real numbers, you're good to go. That's normal. That's how we always graph X is greater than 2. So for X is greater than 2, Caleb, open or close circle on 2. Yeah, there's no line underneath, so we have an open circle on 2. It says greater than, so Isaac, which way do we shade? Yeah, we're going to shade to the right. And because it's real numbers, we're shading all the way to the right. All the decimals, all the fractions, all the numbers in between 2 and 3, except an open circle. Okay, so real numbers is what you know. You should have this graphed on your paper, even if you already know how to do it. So do a quick number line. Doesn't have to be perfecto, but I do want to see it. Another one. So graph X is. Ella, how do I read this symbol right here? Yes, this is not less than or equal to -2. And the domain is positive integers. That's very important. Make sure you write that down. All right, so we need to write down positive integers for our domain. Go ahead and draw a number line. We're going to graph it. So the first thing we always do when we have the not sign is we rewrite it, okay? And you should show what that is on your homework. I want to see on your homework what that actually is. So Dylan, if X is not less than or equal to -2, what do we change that to? It means the same thing as if it is not less than or equal to, that means it has to be, nope, greater than -2. Okay, so it switches and the bar goes away. You always do the opposite. If it's not that, then it has to be that. All right, so X is greater than -2. Normally it would be like open circle, shade right, good to go, right? But our domain is positive integers. Integers are which numbers? -1, -2, -3, -4, -5, forever, 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 0, 1, 2, 3, forever, 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 right? So we can only do dots. We can't shade any of the fractions or decimals in between the dots. We only want to be right on the number line, and we only want positive integers. So, is -2 a part of the solution? No, because it's negative. Is -1 a part of the solution? No, because it's negative. Is 0 a positive integer? No, 0 is not positive or negative. So the first answer is 1. That was weird. And so the next one is 2. And the next one is 3. And you can't shade in between. You have to have just dots on each number. And then 4, and then you have to show that this goes forever. So I want the head of an arrow. Just the head. Don't connect it, right? Because there's no decimals and no fractions that are a part of our solution. So my answers are 1, 2, 3, 4, 5, 6, 7, 8, 9, forever up, right? All right. Okay, X is, Nate, how do I read this sign? That is the exact same thing as X is greater than 4, but how do I actually read this part here? Good. X is not less than or equal to 4, therefore it's greater than 4. So you have to write down on your answer sheet, X is greater than 4. And then it says domain reals. Does reals include fractions? Yes. Does reals include decimals?
Yes.
Yes. Okay, it includes all the integers, all the whole numbers, all the everything, right? It's all the rational and the irrational numbers. It's everything. So this is your normal number line that we graph. So Nico, open or close circle on 4. Yep, open circle on 4. It says X is greater than 4, so Jordan, shade right or left? Yes, because it's greater than 4, we would shade right. So if it's ever real numbers, you should be good to go. It's like what you always do, right? You have to be careful when you get integers or something like that. Positive integers. I know that looks weird. That says positive integers. All right, so X, write that down, is less than 1, domain positive integers. X is less than negative 1. So according to our X is less than negative 1, the solutions would be numbers that are less than negative 1. Give me an example of a number that's less than negative 1. Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, right? And all those lovely guys. But what does our domain say? Positive integers. So it has to be true for both. So what is our solution here? We learned the symbol for this the other day. I thought I heard Corey say it a minute ago, but I'm not sure. Maybe he didn't. Is there a solution, you guys?
No.
Can we graph anything that fits both of these statements? No. There's no number that is both a positive integer and a number less than negative 1. Therefore, our solution is the empty set. So you don't have to graph these. Yay! Just put the empty set. All right? All right, additive property of inequality. All that means, you guys, is you solve it. We can add something to both sides, which you already know. You guys already know this. So go ahead and write this down, though. X minus 5 is less than 0. So Micaiah, what's the first step to get X by itself right here? Yes. So in order to get rid of a minus 5 here, we add 5 to both sides. So you do the opposite here. Those cancel, and we get X is less than 5. Definitely write down your domain. Domain is integers. Does integers include fractions? No. Does integers include decimals? No. Integers are 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, like forever and ever and ever, okay? So, let's see. Evie, open circle on 5 or closed circle on 5? Open circle on 5. And our domain is integers, and it says less than. So, Andrew, where should I put my dots since it's integers? Good. So this says less than. It is pointing to the left, and it's only dots. 4, 2, 1, and an arrowhead because it goes forever. Do I need this open circle right here? No, we actually don't, because we don't have anything shaded up into that point. When we were doing reals and we did an open circle, we had to do that because we were shading. It was every single decimal and fraction right up until you got to that whole number, right? But now, since we're just doing integers, We do not need that, so let's erase, let's erase, okay, on the 5. So it starts at 4, 3, 2, 1, and goes forever to the left. This is everything that is less than 5. Integers that are less than 5. That looks really good. All right, Leah. I'll probably count off point, yeah. Try not to do that open circle. It's tempting, I know, I do it too. All right, let's do this one. X plus 2 is less than 5. So first we need to isolate the x. So Nick, what's the first step? Yep, subtract 2 from both sides, so we get x is less than 3. Ben, what is my domain? Okay, numbers less than 3. Is it everything, though? All the integers, all the fractions, all decimals? Right. Only integers that are less than 3. So, Aaron, where should I start? Should I do the open circle, though, you guys? No, only if we're doing reals do you need the open circle, right? So, we're going to start where, Leah? Yes, we're going to start at 2, and we're going forever to the left. 1, 0, -1, and put an arrowhead. I would like to see at least 3 dots in one direction, and then an arrowhead. Okay? Let's try it out. Let's see how we do.